All right, folks, we're back in 10.4 and we have more examples. This section has tons of vocabulary, tons of examples, so stick with me. This is probably not going to be the last video, but it might be, but I don't think so. We got a lot of examples here. So some books define trapezoids as quadrilaterals that have exactly one pair of parallel sides. So we're going to draw a Venn diagram showing how the categories of parallelograms and trapezoids are related when this alternate definition of trapezoid is used. So now we're bringing in Venn diagrams and shapes here. So first, let's see here. What is the definition of a trapezoid? In this case, a trapezoid has exactly one pair of parallel lines. So that means not 0 and not 2, right? And they want us to compare parallelograms. So what's our definition of a parallelogram? A parallelogram has exactly two parallel sides because opposite sides have to be equal. So both have to be equal. Well, if you have exactly 1 and exactly 2, there's nothing in common there. So if I was to draw a Venn diagram, they would be totally separate. This would be trapezoids and this would be parallelograms because they don't have that in common. And here's it written out for you. And then you go ahead and give these 3 a try and press play when you're ready to see the solution. And there you go. So now we're going to move into construction. So you are going to need some supplies as we move forward, especially in the example problems. But so circles are actually going to help us make triangles. And it may seem strange because circles are round and triangles are straight. But in the next examples you try as an explorers, we're going to see how to make triangles and quadrilaterals in these 3 ways. By drawing circles, folding and cutting paper, and by doing this walking and turning to trace a route. All right, so let's do an example here. So let's first look at this. We're not going to construct it ourselves. We're just going to look at this construction. So use this method. Oh, so I just lied. I said we weren't going to do it, but we are going to do it. Use this method to draw 2 different isosceles triangles. So let's look at the method. We're going to draw part of a circle, and then we're going to connect the center of the circle with 2 points on the circle. So this makes an isosceles triangle because what is this? From the distance from the center of the circle to 2 points on the circle, well, those are the radius. So we know that the radius is always equal, and then this is just connected to 2 different points. So if I was to draw a circle here, let's say I drew a circle, and this is going to be bad because I don't have my compass, right? And they want 2 different isosceles triangles. So I know that if I go like this, those are going to be isosceles. But that is going to be different. Now, what if I didn't want to even draw a new circle? What if I just wanted to draw a different isosceles triangle? Well, those are still the radius. I just connect those. Now, use the definition of circles to explain why this works. Well, I just did. We're dealing with the radius, and that's always going to be equal. So this is a foolproof way to always draw isosceles triangles. So now it wants me to draw an isosceles triangle that has 2 sides length 6 inches and 1 side length 4. So what I would do is if I want 2 sides that are length 6, what this is saying is I need a radius of 6 inches. So this, let's just say this is a scale 1, 2, 3, 4, 5, 6. And then that would be my center, 1, 2, 3, 4, 5, 6. And so that would be my radius. And then let's say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you would get out your ruler here and your compass. Now I know that a triangle, this is going to be 6 inches. And then I would just get my ruler and make sure I measure that that is 4 inches. I encourage you to do that on your own here. Okay, so now it's saying use a ruler and compass to help you draw a triangle that has 1 side of length 5 inches and 1 side of length 3.5 inches and 1 side of length 4 inches. Okay, now I'm not going to use an isosceles triangle. I could use the radius, but now I want 3 different side lengths. So now let's think about this. And I'm going to let each square here be 1 inch to help me. So I'm not doing that ugly thing that I just did. So if I know I want one side to be length 5, so let's see here. Let's kind of go in the middle. 1, 2, 3, 4, 5. This is 5 inches. I know I want one to be 5 inches. Now I want the other side to be 3.5. Well, let's make a radius that's 3.5 inches. And so I know that if I make this the center of that circle, and I go 1, 2, 3.5, and I go 1, 2, 3.5, and I go 1, 2, 3.5, and I go 1, 2, 3.5. Anything on this circle here that connects to this is going to be 3.5 inches. So I'm almost there, right? So now let's build 4 inches. So I'm going to make another radius that's 4 inches, but I'll do it over here. I'll make this the center that's 4. And see, I'm in a bit of a bind here because I don't have enough space, but 1, 2, 3, 4, 1, 2, 3, 4, and it's fine because I don't really need the whole circle. 1, 2, 3, 4. So when I kind of go like this and like that, right, and it should be more like that. There we go. And I'm going to pull from this spot because I want it to connect, but it doesn't matter because anywhere from the center to that is going to be 4 inches. And so using circles, I have made a triangle with 3 different sides. And why does this always work? Because the radius of the circle, I can determine the radius of the circle, and then I know that anywhere I put a line from the center is going to be that value. Now this next one's going to get a little tricky, and I'm actually going to be using GeoGebra software, so let's hope that that loads nicely for us here. So we've got line segments A and B, and I'm going to draw, those should be in here, let's see. All right, here we go. We've got line segments AB and BC constructed so they could be 2 sides of a rhombus. Well, what do we know about a rhombus? A rhombus has 4 sides that are all the same. So now it wants me to trace the angle BAC on a piece of paper. So I'm using GeoGebra here. So I've traced it. And now it wants me to use a compass and straight edge to finish constructing a rhombus that has AB and AC as 2 of its sides. So, okay, let's think about this for a second. If I want AB, if I want this triangle, and let's make this, oops, let's go ahead and move this over here. And let's get rid of this guy here. Let's move this over. And we don't really need, we don't need the axis or the grid really. Okay. So now let's see, we want, if I was to just kind of draw this, we want, 2 more sides, and we want these 2 sides to be equal. So if I make this a circle, so if I set a compass to the length of AC, this is AC, if I set a compass to the length of AC and I center it, right, that's A, and I center it at B, right, so I know it's going to be the same length, but I center it over here, then I can move that, kind of anywhere around, and I can get a length of this, I can get a side length of the same value. So let's go ahead and let's make a circle. And I have changed these letters here so they match a little better. My apologies. So we want to make a circle, and we want a center point, and we're going to select the radius. Now I know that the radius, here I know that the radius is 2.53. Now you and your compass, you can just you can set the distance to be the length of AC. So I know I want the center to be B, and I want the radius to be 2.53. And so there we go. We have a center B, and then let's go ahead and do the same thing with a center of C. And I know I want the length to be 2.53. So what we see here is that I should be putting the point of intersection right here should be my point D. And then if I make a rhombus, okay, let's see. If this, from B to any point, I want a line segment. From B, this is center B, to one of my circles, to my circle. And I know that that's going to be length AC because I made it that way. And when I take center C and I put it to the circle, then it's going to be the same length. So that is how you can construct a rhombus. And it's a little tricky. I definitely see that. Let's see if I can draw in here. Oh, look at that. Okay, that's great. So again, I've got my center B, and this circle here, anywhere along the circle, remember, I made it so it's the same length, 2.53. Now remember, I could have just used the length of AB because they're equal, so I didn't really need to make a 2.53, right? But so anywhere along this circle is going to be the same, is the length that I need. But so if I make it where they intersect, then this length here, they're going to meet, and they're all the same length. Go ahead and give these 3 problems a try. Press play when you're ready to see the solution. And we're going to do one final video with an exploration and some examples, and then we will be done with 10.4 in the next video.